Okay, so this is sort of a walkthrough video for one-dimensional kinematic 7, average versus instantaneous velocity. We are going to be using graphs to find that. This is obviously from standard ICP 2.2, describe the differences between average velocity and instantaneous velocity, and be able to determine either quantity given a graph of position versus time. So we've been looking at these position time graphs a lot. Hopefully you've already done your Bellringer before you got to the video today. So we're going to kind of look at the lesson, and we'll be in our notebook as well, kind of taking some notes on average versus instantaneous velocity. So let's go ahead in our notebook and title our page, One-Dimensional Kinematics, Lesson 7, Average versus Instantaneous Velocity. Average versus instantaneous velocity. Okay. So, average, what does that word even mean? When we think about average, we think of like the mean. We add them up and divide by the number of numbers. So it's kind of a number over time or a number over occurrences. Or occurrences.
All right, everybody. Looks like we are ready for those of you that are leaving.
All right, so average could be over time or over the number of occurrences that we have. Instantaneous is at a specific point, a specific time. And that's kind of hard to come by sometimes. Most of the time, what we're going to be looking at is an average velocity. Okay, so let's go ahead and look at the graphs that we have here. These are position and time graphs, so we know that position is on the y-axis, and we can see that meters for the units there, and time is on the x-axis with seconds as our unit. So you're going to get questions that look like this. What is the average velocity between 0 and 4 seconds? If we look at our graph here, we have 0, here's 4 seconds. So we can see, all right, what are we going to do with, how do we find the average velocity between 0 and 4 seconds? First of all, we need to remember this is a graph, okay? And we know that slope is velocity on a graph. So let's write that in our notes just one more time. Okay. So if we look at this particular graph, okay, our time is our x-axis, our position is our y-axis. So if we were to create points, okay, the initial point would be x is 0. X is 0. Y is 1. And our final point is x is 4 and y is 3. So you can kind of see that strategy there going right from the point that we have and straight over. So we can find our actual point for our scatter plot graph. Okay, sorry for that interruption. But if we know that slope is velocity, we know that we are going to find the rise over the run. So slope also equals rise over run. You probably remember from math classes that we would have y2 minus y1 over x2 minus x1. Okay, we could also look at this as the change in position over the change in time. Okay, so if we look at this graph, we know that position is the y-axis, time is the x-axis. So we're saying the same thing. So let's go ahead and figure the slope for this. So if our final is 4 and 3, we know those are going to be our x is 4, our y is 3. So that's y2 and x2. Okay. And our initial, our x is 0, our y is 1. So our slope 3 minus 1 is 2. Over 4 minus 0 is 4. So it's 1/2 meters per second. Okay, if we wanted to be super official, we would have had our units on our numbers from the graph already, and we would say meters per second. So we want to make sure that we have a good unit. And our velocity, the average velocity between 0 and 4 seconds on this graph is 1/2. Okay. So let's go to the next question. What is the average velocity from 4 to 6 seconds? We go 4 to 6 seconds. Well, this is a straight line. Anytime we have a horizontal line, we know that that's going to be 0 meters per second. So we will go ahead and write that in our notes just to make sure that we are following it. Okay. So that position does not change over the course of that entire time. All right. Now, we could go ahead and do the math for that, as we probably should. What is the average velocity from 4 to 6 seconds? So let's go ahead and prove our 0 meters per second statement here. If we know that our initial point would be the first, initial means first, the first point, our x is 4, and our y is 3. And our final point, so at 6 seconds, we go our x is 6, because we know that's the time it's asking us for, and our y is 3. So when we go through the process of finding the slope of the line that we've already done before, we're going to say y2 minus y1 over, and we could even go as far as to say time 2 minus time 1, just to be a little more official. So our y is 3 minus 3, and our time, the final, 6 minus 4. Okay, so we're going to get 0 meters over 6 minus 4 is 2 seconds, but we know that 0 over anything is really 0 meters per second. So any horizontal line, we are going to get 0 meters per second, because our y is going to be the same for a horizontal line. Okay. All right, let's look at that next question in these examples. What is the average velocity from 6 to 9 seconds? So 6 to 9 seconds. Let's go ahead and look at our initial point would be x is 6, and y is 3. And our final would be at 9. So our x is 9, and our y is 0. So if we're going to go y2 minus y1, or position final versus minus position initial, I always write my formula because it just helps me keep my numbers a little better. So I know I'm starting with the final. My y is 0. My x is 9. So my initial, my x is 6. My y is 3. So 0 minus 3 gives me a negative 3 over 3. And so I get negative 1 meters per second. Again, we have position, so our position over time. Position over time. Make sure our unit is correct. Negative 1 meters per second. Now, wait a second. Let's consider this. The first part of our graph that we have on the screen here was 1/2 meters per second. That's a positive number. So we are going away from the origin. Then we sat there and waited at 0 meters per second. And then we went back to the origin at negative 1 meters per second. So that negative tells us a direction. Let's make sure that we take a big note of that. In this case, that direction is back to the origin. Okay. All right. So let's go ahead and look at the second graph here. I'm just going to go ahead and give you these examples so that you'll be ready to do that exit ticket. If we're looking at the second graph, so in our second graph, what is the average velocity between 0 and 3 seconds? So here's 0, here's 3. Our initial x and y, we're going to start at 0, 0. And our final x and y, our x is 3, and our y is 6. Okay. So what is the average velocity? We're going to say y2 minus y1 over x2 minus x1. So if I know that my y2, that's final, that's the last one I'm going to, we have x and y. So I can go 6 and 3. Sometimes it helps if you write both of your 2's first. That way you don't get your numbers mixed up. Then you're going to write both of your 1's. So we get 6 over 3 equals 2 meters per second. Okay. So we had rise over run, or change in position over change in time, gets us 2 meters per second. I need to do a better job of putting these units in my instructions there. What is the average velocity from 3 to 5 seconds? Well, 3 to 5 seconds, that's a horizontal line. And we proved that that is sitting still. So our average velocity from 3 to 5 seconds is 0 meters per second. We're standing still, standing at that 6 meter position for 2 seconds. All right. The average velocity from 5 to 8 seconds. So let's go ahead and do this one. Our initial point on the graph is our x is 5 seconds. And our y is at 6. On our final point for that, it says 8 seconds. So our x is 8 seconds. We know that x is in seconds. Okay, we could go ahead and add those units there. And our y at 8 seconds is 3 meters. Okay, so when I plug that in, always write your formula. It helps your brain to remember it. So I'm going to say this is my second one. My y is 3 meters. My x is 8 seconds. I'm going to subtract my initial. So my y is 6 meters. My x is 5 seconds. So, 3 minus 6 is negative 3 meters. 8 minus 5 is 3 meters. So I'm going to get a negative, no, what isn't? 8 minus 5 is 3 seconds. Sorry, distracted. So I'm going to get a negative 1 meters per second. Okay, so now let's compare here. The first part of this graph, we were going 2 meters per second away from the origin. The third part of the graph, we had a pause. The third part of the graph, we were only going negative 1 meters per second. So we are slower. Notice the steepness of the line is less. So the first part is more steep. The second part is more gradual of a decline. Okay, the steeper the line, the faster we're moving. Right? And then we have another pause right there. I think that is probably enough examples for us to write down for today. We'll go through some more during class. Please do the exit ticket.